Have you ever stopped to think about how a self-driving car actually sees the road? Or how a drone from way up high can perfectly track a moving object? We're about to pull back the curtain on that magic because it's one of the biggest challenges in AI. Teaching a computer not just to process pixels, but to see and understand the world with an intuition that's almost human.
Okay, so let's boil it all down. Forget the complex algorithms for just a second. At its heart, what we're really doing is teaching a computer to play a high-stakes game of I Spy. But here's the catch. It has to be perfect. It can't afford to miss that car partially hidden by a tree, and it absolutely cannot mistake a weird shadow for a vehicle. It has to be flawless every single time, and it has to be lightning fast. So, how on earth do we do that?
Well, for a long time, the approach was, let's just say, slow and clunky. Imagine trying to read a page in a book by looking at just one letter at a time. That's kind of how the old systems worked, scanning an image over and over again. Then a totally revolutionary idea came along called YOLO, which stands for You Only Look Once, and it does exactly what it says on the tin. It takes one single glance at the whole picture and, bam, it finds everything, all at once.
And this one-glance philosophy is what makes YOLO a total game changer. I mean, it's not just a little improvement, it's a completely different way for computers to see. This incredible speed is why it's the go-to for anything that needs to happen in real time, where split-second decisions matter. It's the difference between analyzing the world after it's already happened and reacting to it as it unfolds. So let's see how that reaction is even possible.
So, how does an AI actually look once and just get it? Well, under the hood, it's a really elegant two-part system. The easiest way to think about it is that the AI has eyes that process all the raw visual stuff and a brain that makes the smart decisions based on what those eyes are seeing. First up, let's talk about the eyes.
The eyes of our AI are something called a convolutional neural network, or CNN for short. Now, a CNN is an absolute master at recognizing patterns. It basically breaks an image down layer by layer. The first few layers might just see simple things, like basic lines, corners, and colors, but then the deeper layers start combining those into more complex shapes, like wheels and windows and headlights, until it's built this incredibly rich mathematical map of all the visual patterns in the picture.
But just seeing a bunch of patterns isn't enough, right? You need some intelligence to make sense of it all. And that's where YOLO comes in as the brain. It takes that super detailed map from the CNN, and in one single unified shot, it figures out what all those patterns are and exactly where they are in the image. It's a brilliant system. The CNN provides the raw vision, and YOLO provides the perception.
So here's how that one glance actually works. First, YOLO just throws a grid over the entire image. Then, for every single cell in that grid, it asks a bunch of questions all at once. Hey, is the center of an object in my little box? If so, what's its exact size and position? And, how confident am I about this guess? It does all of this for every cell, for every possible object, all at the same time. That's the secret to its insane speed.
Now, you can have the smartest brain and the sharpest eyes in the world, but they're useless without any experience. And in the world of AI, experience comes from data. The quality and the variety of the images you train your AI on, well, it isn't just important, it's literally everything. And AI is only as good as what it's already seen.
And I'm not talking about a couple hundred photos from your vacation. No, to build a model that can actually handle the messiness of the real world, you need a massive, massive library of images. We're talking thousands, tens of thousands, sometimes even millions of pictures where every single car has been painstakingly outlined and labeled by a human being. But just having a ton of images isn't the whole story. The data has to be perfectly balanced, kind of like this AI diet you see here. Just imagine if, say, 90% of your training images were just side views of cars. Well, your AI would get amazing at spotting cars from the side, but it would be completely useless if it saw one from the front or from above. You need an even mix of every possible angle to build a model that actually works. This leads to a really fascinating problem. The world is just full of things that are kind of car-shaped but aren't actually cars. So how do you teach an AI to tell the difference and not get tricked by all these lookalikes?
This stuff is basically the AI's kryptonite. From a drone's point of view, a rooftop solar panel can look a lot like the top of a car. A big garbage bin can look like the back of an SUV. And simple things like empty trailers, cars under tarps, or even just weird shadows and reflections can easily fool a model that hasn't been trained properly, which could lead to some really dangerous mistakes.
And the solution is so beautifully counterintuitive, I love it. You don't just show the AI what a car is. You have to explicitly teach it what a car isn't. By feeding it thousands of pictures of these confusing objects and labeling them as not a car, we call them negative samples, the model actually learns to ignore them. So here's the key takeaway. Teaching an AI what a car isn't is just as important as teaching it what a car is.
All right, so we've established that collecting millions of perfectly labeled and balanced images is a huge pain. It's expensive and it takes forever. So what do you do if you have a limited set of data? Well, this is where developers get really clever and find ways to basically create new data out of thin air.
It's a technique called data augmentation. We can take just one good image and spin it off into dozens of new variations. We can flip it horizontally, boom, a new perspective. We can rotate it a little to simulate a different camera angle. We can change the brightness to look like a cloudy day, or randomly crop it to make the car look partially hidden. Each one of these little tricks helps us multiply the size of our data set without ever taking another photo.
And some of these techniques are even more creative than that. One of my favorite methods is literally cutting a car out of one picture and pasting it onto a dozen totally different backgrounds. You can put it on a city street, a desert road, a dark parking lot, and every single time you paste it, you've just created a brand new, unique training example. It's a brilliant way to expand the variety of your data.
And now we're heading into an even crazier era. Instead of just tweaking the photos we have, we can use other AIs like Stable Diffusion or DALL-E to generate completely new photorealistic images from just a text description. We can literally type a blue sedan partially hidden behind a bus on a rainy street at night, and the AI just makes it. This is absolutely the future of training data.
So, after all of this meticulous work, getting the data, balancing it, creating more of it, and then training the model for hours and hours, what's the final result? How do we even know if it all worked? Let's get to the payoff, where all those raw pixels finally turn into real perception.
We measure success with a few key numbers. First, there's precision. That asks, of all the things we said were cars, how many were actually cars? This is super important for avoiding false alarms. Then there's recall, which asks the opposite. Of all the real cars in the picture, how many did we manage to find? This is about not missing anything. And then a metric called MARP cleverly combines both of those ideas to give us one single score for the model's overall accuracy. And the final result? It's that super-powered I Spy player we were talking about. A really well-trained YOLO model can now spot cars from any angle, even if they're mostly blocked from view. It can handle terrible lighting, bad weather, motion blur, and it can even find cars from a drone thousands of feet in the air, all in a fraction of a second. It's truly incredible. And you should know, this technology is not standing still. Not at all. The original YOLO back in 2016 was a huge breakthrough, but the field has been moving at a blistering pace ever since. Every couple of years, new versions come out that are way more accurate, way faster, and easier to use, with the latest models like YOLO V8 just constantly pushing the limits of what's possible.
And that really brings us to the final big picture thought here. This whole process we've just walked through, this amazing combination of a powerful model, carefully curated data, and really smart training, it can be applied to almost anything. So if we can teach an AI to see cars with this incredible level of detail, what should we teach it to look for next? What problems in medicine or science or public safety could we solve by giving our machines the power to see the world in a completely new way?